Now, let's bring our attention back to what we started about the comparative statistics. So now you've been able to understand the demand function, the assumptions underlying the demand function, talk of the homogeneous rule, and that of the Lorentzian law. Now, what happens when there is a change in any underlying economic parameter? Talk about the price or the wealth. All right, so that's what you call the comparative statistics, but just a little bit for understanding. Now, with comparative statistics, we want to understand what happens to the consumer's choice when there's a change in his price or wealth. Of course, it's clear when there is a change in price, you could either consume more or less. Same way, when there's price constant and there's a change in wealth, you could either consume more or less. So that's what we're going to talk about today. And so just briefly, comparative statistics has to do with changing the parameters and seeing the effects on the demand function, where static analysis tries to understand how to achieve equilibrium price, how to achieve equilibrium quantities. So the comparative statistics, you'll be using the derivatives, you'll be using the elasticities also, just a clear distinction so you know what we are talking about going forward. Right. So remember the Lorentzian law, which says that the whole expenditure, the whole budget, wealth should be spent on the consumption such that expenditure will be equal to your wealth, no excess demand and no surplus demand. All right. So when this happens, what happens when at the same price, constant price, there is a change in your wealth, either as wealth increases or decreases? The result of that wealth effect is called the Engel's function. We are going to express it on the utility curve here. Now, let's take a look at this diagram. Let me just zoom in a little bit more. Okay, I thought I could zoom in, but it's not working. So let's just go ahead. So we are seeing this line, and this budget line. So it's from the lowest to the highest. Now, anytime there is an increase, anytime there is an increase in the consumer's wealth, price is constant, it shifts the budget curve upwards. And so the consumer is in a better position to buy both more of X and Y. So it happens to the third budget line also. Now, at any time there's an increase, the consumers, initially, he was consuming at this point. Now, with an increase in wealth, constant prices, he's able to buy more of both X and Y. So he's moved to this budget line. Similarly, another increase in wealth takes you to this point. So it suggests that with an increase in wealth, you'll be better off to buy more of both commodities at the same time. And that is why when you join both consumption paths, you get what we call the Engel's function, and that is the wealth expansion path. Take note. So with constant prices and increase in the wealth of the consumer moves from one budget line to the other budget line, where he's able to buy more of both commodities. Now that part, when you join those bundles together, that produces what we call the wealth expansion path. So take note about that. Right. So now we're going to understand another thing about the wealth effects again. So just typically, when there is an increase in the budget, in the wealth, there are two things that happen. And let me take you through quickly. Why do we see consumer buying more of a good when there's an increase in wealth? And what happens when we see the consumer buying less of the same commodity when there's an increase in the consumer's wealth? Now, at an increase in wealth and the consumer decides to buy more, that commodity is exhibiting what we call the normal good. Now, at a point in time, when he begins to buy less, even at an increased wealth, that commodity begins to exhibit an inferior good characteristic. Why does that happen? It depends on how the consumer is seeing both commodities. Okay, so let's see, take a typical example, bread. If the consumer decides that all the food in this world were to be bread, no other food but bread. Talk of food, he knows of bread. And there's an increase in wealth. The consumer still wants to buy food. All he knows is bread. So the moment he thinks of food, it's bread he buys. So you can understand that with an increase in wealth, the consumer wants to buy food, only bread he buys. So bread will also increase. Then bread becomes a normal good. That is called large aggregate. The consumer is viewing food as in its large aggregate. Now think of another consumer who is able to segregate food into categories. Okay, so we have low degree food, middle degree food, and high degree food. Assuming the consumer started by consuming the low degree food, and there's an increase in income of the consumer, what happens is that now he's in a better position to afford the higher degree. So this time he's better off, so he begins to dump the low degree and begins to go for the high degree. Note, this time the food has been segregated. And so the consumer is able to decide, let me go for the next quality food. Let me go for the next tasty food. In that sense, you see that the low degree food is now less demanded. Now you're going to buy more of the high demand. So the low demand food now begins to exhibit inferior good characteristics, where we are buying less, even at higher income. So what this means is that it depends on how the consumer sees the commodity. If he sees the commodity as in very much disaggregated, then they will exhibit inferior good at an increase in income. But if he sees that commodity in its total aggregates, then it will become a normal good. With any increase in income, more will be consumed or more will be demanded, either way. So this is how we're going to express it on the matrix, for instance. So take differentiating the demand function with respect to wealth. So we are talking about change in demand over change in wealth. So talk about the first commodity, change in demand over change in wealth. That is the wealth effect. Talk about the second commodity, change in X2 over change in wealth. So if you have several commodities, it goes on and goes on until the last commodity. Great. So that is how the price effect occurs. So it's either going to be a normal good or an inferior good, depending on how the consumer views the commodity. Does he view it as an aggregate, or does he view it in its disaggregated form? Each of them has its effect. Now let's look at the second part. Now we are going to hold wealth constant and we are going to change our prices, either prices. All right, so I'm going to get quick over here because I know you get this already. So now we are going to differentiate the demand function with respect to price of a commodity. Price of a commodity. So let's look at this diagram. This diagram with X on the x-axis and good Y on the y-axis. So supposedly there is a decrease in price of commodity Y. What happens is that Y becomes less expensive, so the consumer can now buy more. And so we see the budget line pivoting on the x-axis, whose price is constant, but then buying more of y-axis. The same thing happens to second graph here. Suppose there is a decrease in price of commodity X. What happens is that X now becomes cheaper, so the consumer can now buy more of commodity X, but then the same amount of Y, because Y's price hasn't changed. So the budget line will pivot on the Y-axis. Now that is called the price effect. That's called the price effect. Great. So just to get you through it over here with a little bit of a diagram. With price effects, what happens to a normal good, it also derives an expansion path. By this time, it's not going to be called a wealth expansion path, but it will be called the offer curve. So this happens over here. So just like we did for the wealth expansion path, this leads to what we call the offer curve that way. Now note, we are shifting, we are pivoting with every decrease in price of commodity Y. So each of them happens that way. But when you get to this graph, which is referring to an inferior good, now understand, normal and inferior relates to changes in wealth. But when we talk about normal and inferior, which changes to price, then they are called an offer curve and a given good. So this curve over here suggests that the higher, as you reduce the price of a commodity, initially you were able to buy more of commodity Y, as you can see from here. But with another another decrease in the price of commodity Y, we are expected to buy more. By this time, you can see from here, the quantities are falling now. And so the curve is now bouncing downwards. That means with lower prices, we are rather buying less. Such a commodity is called a given good. So with all the price effects, we can see it from here. We differentiate the demand function with respect to the prices. So the first commodity 1, differentiated with price 1, then that gives the own price elasticity. You can differentiate commodity 1 with respect to price 2, and that gives the cross price elasticity. So it goes on and on until the last price of the commodity. You can also trace it downwards. Then let's see commodity X2 with respect to price 1, and that will also be cross price. Commodity X2 with respect to price 2, and that will be own price elasticity. So this is going to happen to determine the price effect. So in summary, the price effect produces what you call the offer curve and that of the given good. But the wealth effect produces what you call the normal good or inferior good, depending on how the consumer views the commodity. Great. Now, coming to an end, let's see what does the price effect and then the wealth effect, such that the changes in prices and changing wealth, do they have any implication for the Lavoisian law and that of the homogeneous rule? That is possible. So let's look at it from here. Now, what does the price effect and the wealth effect, what implication do they have for the homogeneity rule and the Lavoisian law? So let's remind ourselves, the homogeneity rule suggests that changes in prices, changes in wealth, same change, scalar change in price and wealth should lead to no change in your bundles, the quantity you're able to buy. Okay, so let's see with price effects. Now we are going to differentiate this demand function with respect to price. Okay, but you should understand this is a product rule. Okay, and so we are going to differentiate this with respect to price. Then we keep the x constant and differentiate this also. Perfect. So let's go on from here. So the first part of it will differentiate with respect to price, plus the second differentiation with respect to wealth. Now, when you do this, then you end up getting what you call the Euler's formula, which says that all the price elasticity and all the income elasticity should be equal to 0. And I believe you understand that. For the homogeneity rule, changes in prices, changes in income should have no effect on your bundle. And that is what we are able to express here in the form of elasticity. So change in price, change in demand over change in price, times its price over the demand, original demand, that's the price elasticity. Again, when you differentiate this price wealth bundle with respect to wealth, then you have what you call the income elasticity. So the price effect and then the wealth effect should have no effect on the total bundle. So the total effect we'll see is going to be a combination of price effect and a combination of wealth effect. And that is what you call the total effect, which will be 0. So the homogeneous rule is very critical in understanding how the price effect and the wealth effects behave, such that if the price changes the same margin as the wealth, then there should be no effect on demand. That is the Euler's formula. So bear in mind, the Euler's formula, price elasticities and all income elasticity should add up to 0. Perfect. Now let's also see the implication of price effect and the wealth effect for the Walrasian law. Again, the Walrasian law says that all expenditure should be equal to wealth. So you are going to differentiate these with respect to price, then also differentiate with respect to wealth. So again, when we differentiate this function, the demand function here, the expenditure function, with respect to price, this is what you're going to get. And I believe you can refer to it as in product rule. You keep this thing, you keep price, then you differentiate the demand with respect to price, plus you keep the demand function, then you differentiate price with respect to price, and that gives you this. So differentiating the expenditure function with respect to price produces what you call the Cournot aggregation. Cournot aggregation. Now, the Cournot aggregation is very also critical. It suggests that all the elasticities plus all the share of wealth spent on that particular commodity should also add up to 0. Yes. Now, it suggests that whenever the wealth price changes and the proportion of wealth that you use to consume that commodity are the same, then it means that there should be no effect on your bundle that you buy before. So the amount you buy before, the amount you buy now would also be the same. And the last part of the implication is the wealth effect on the Walrasian law. Again, we are going to differentiate this function. So with the Walrasian law, then we are going to differentiate this function with respect to wealth, so that all these, you hold P constant, differentiate this with respect to wealth. That is what we have here. And then they differentiate W with respect to W again, that gives you 1. Now, this also has a very critical implication called the Engel's aggregation, which summarizes that all the percentages, or quote unquote, all the share of wealth used in buying the different commodities should also be equal to 1. So if I spend 10% on commodity 1, 10% on commodity 2, I should spend 80% on the third commodity. That should exhaust my wealth. So if you have 2 commodities, the percentage you spend on commodity 1, if it's 60%, then it suggests that the remaining percentage should be spent on commodity 2. That should be 40%. All right, so that's the Engel's aggregation. Engel's aggregation makes it clear such that we consume all our expenditure perfectly. So just to wrap up with all that we discussed today, what we said today, we've been able to achieve today is that the Walrasian demand correspondence, which we viewed it from the multi-value demand, can be reduced to a single demand, which is called the Walrasian demand function or the Marshallian demand function. Again, the Walrasian demand correspondence, per their assumptions, is homogeneous of degree 0, and it also satisfies the Walrasian law of no excess demand. Thirdly, we've been able to achieve that the homogeneity of degree 0 of the Walrasian law and that of the with regard to the price effects and then the wealth effects suggests that changes in prices and wealth leads to no change in demand. That is the homogeneity rule. Change in prices and equal change in wealth has no effect on your bundle. Now, note this for the last part. The Walrasian law has 2 implications for the price effect and then the wealth effect, which is the Cournot aggregation and then the Engel's aggregation also. So the Cournot aggregation suggests that all the elasticities and all the income elasticity should be equal to 0. But then the Engel's aggregation suggests that all the income elasticities, all the percentages spent on different commodities should be equal to 1, so that we can be able to exhaust all our resources. This is another lengthy tutorial you've taken. You need to take time, listen to it again over the first time, second time, and you get through demand functions and that of the comparative statics. Thank you for staying with us. Join us in our next video tutorial. Bye-bye for now.